Okay, so now we're going to talk about the area between two graphs. Now this comes up quite a lot, and I know in the last lessons we were really concerned with whether something is above or below the x-axis and how that changes the sign of its area, whether it's positive or negative. But I'm going to show you why, luckily, or like nicely, that when you're working out the area between two graphs, no matter what the configuration is of them above or below the x-axis, it always works out to the same formula. So it makes our lives a lot simpler. So I'm going to show you what I mean. So if I want to know the area between two graphs, okay? So just say I wanted to know the area between f of x and g of x. So that's this area all here in the middle, right? But obviously we're going to look at a certain section. So if I said, okay, I want to know the area between the graphs f of x and g of x between a and b. So what's the best way to work that out? Well, what you'd want to do is, I'm going to change the color of my highlighter, seen behind the scenes here, and this one here to red. So what we'd do is we'd say, okay, well, think about it, the area between f of x and the horizontal line, you just calculate like this. Okay, we know how to calculate that, easy peasy. Fine. Okay, now if I want the area between the two of them, well, I can see that just the difference in area would just be whatever f of x was minus whatever g of x is. So just minus this bit, right? Fine. So what does this look like in maths? So this would be, I want the area from a to b of f of x minus the area of a to b g of x dx. And as you can remember from before, with the integration rules, we said with addition you can just put them in the same bracket. It's exactly the same with subtraction because they are basically just the same thing, aren't they? So here you have b to a, and you're going to have f of x minus g of x. Okay, and that's going to give you the area between the two, right? That makes sense. And here, that is all going to be positive area because it's all above the x-axis. And this is also going to be all positive because it's above the x-axis. So happy days, everyone's happy. But what if we've got a different scenario? What if I want to know the area between the two graphs where, some of it's above and some of it's below, right? Well, pretty simple. Okay, well, I think, what's the total area? It'll be this area in blue plus this area in red. Okay, now what happens if when you just go and you start to do this integration thing again? Will it still work if you still do the top function minus the bottom function? Let's just see what happens. So you're left with equals the integral between c and d of f of x minus, because it's always minus, the integral between c and d of g of x dx. Okay, now the difference here is that this is still positive, this is still above the x-axis here, but this part is going to be negative, right? This is all negative. Well, this is positive because we know that when you calculate something below the x-axis, you get a negative value. So what happens here is this ends up being minus a negative, so it ends up being positive, so it ends up just being the top half and the bottom half added together. So that actually simplifies itself. So you can just write it like this. Again, integral between, c and d of f of x minus g of x, okay, dx. Don't forget your dx's. Okay, brilliant. Now, what happens here? right? So what if both of them are below the x-axis? Then surely they're both just going to be negative, right? Well, it's kind of like, well, it's just the opposite, really, isn't it? So it's this red section of g of x goes from here, from the line all the way to the x-axis, whereas let's see if I can make that come out on top. Whereas the f of x just covers this little bit here. So whereas before, it would have, here you think, okay, the total area minus this one. What we really want is this total area minus f of x. But will that work out that way? Well, let's look at the maths. So you integral between f and e, f of x minus integral e to f g of x dx. So what's going to happen here is this is going to be negative and this is going to be negative. So actually this becomes a net positive and this remains negative. So you have, this is calculated as a positive area minus the blue area. So then it just works out again perfectly. So you're left with exactly what you want, and all you have to do, again, integral of f e is f of x minus g of x dx. So maybe that was a bit, time consuming, but I just wanted to show you that no matter what the scenario, it always works out to this formula. So here's the official definition, if you will. So the area between two curves, y equals f of x and y equals g of x, from x is equal to a to x is equal to b, can be represented by this formula here. So the integral of f of x between a and b minus the integral between of g of x between a and b dx. You can substitute this in here, like I showed in the previous examples, where you have f of x minus g of x dx and use the same limits. But for this to be true, f of x needs to be larger than g of x, okay? And a needs to be smaller than b, okay? It needs to go from bottom to top. So basically, in this range here, you can see that f of x is the greater function, okay? It's the bigger one rather than g of x here at the bottom. So you need to make sure you are confident which one is the larger function, because it's only the top minus the bottom. That's only when this stands true, okay? But hope that makes sense. We'll go do an example now.